Hello, my name is Atsu CC Manigar, and I'm going to be talking about integrating Alexa and App Inventor. So first, what can we do with App Inventor and Alexa working together? Well, let's look at this example, an interactive storybook app, where we have the story of Bambi in an app, and then you, the hypothetical reader, could say, Alexa, read me the story, and Alexa will start reading the story to you. But that's not all. You could also, for example, ask if you could talk to Bambi, and Bambi could respond depending on where on the story you are. So how do we do this? Well, first, you need a voice user interface, which you can use these blocks to make. These blocks define the skill that you're trying to initialize, the invocation that your skill will create, and then an intent, which is something for Alexa to do. So for example, this intent tells the story. It reads the part of the story that you're on. And to do so, you use one of these trigger phrases that you put inside the block. This VUI block is converted to a JSON that is used inside the developer console to create the voice user interface on the Amazon website. So let's see how this works in practice. In App Inventor, we have these blocks, starting with the when skill initialize block, and that block is located here, skill 1. So you pull that out, and then you define the invocation and intent from the voice blocks. So the invocation is the name of your skill. These various intents are the default Amazon intents, and then you can define your own custom intent using phrase lists that you define here. So once this has been defined, you go back to the designer, you log into Alexa, which I've already done, and then you send updates to Alexa. And if everything goes well, you should get a pop-up saying skill updated successfully on Amazon. And then if you go to the Amazon developer console, you could see the skill in the developer console, and you can test it and build it from there. You can see the JSON shows the same phrases that you defined in the blocks. Okay, so that's the first part, the voice user interface. But how does Alexa know what to do once you've said those trigger phrases? That's the second part, the endpoint function. When the intent is spoken, when the phrase that triggers this intent is spoken, then it triggers the function inside that block. So first, it checks which page you're on, 1 or 2, and then it says whatever is on that page. Say is telling Alexa to say what was on the page. And then it'll send the value true to the app to tell the app that Alexa is done reading. This code is converted to JavaScript and used to create the endpoint function for Alexa. How that works is we have the second set of blocks here. These come from the bottom of the voice drawer. So when the intent is spoken, the say, send value, get value, and the machine learning block, which we'll talk about later. And once you've defined these blocks, then you have to do a bit more involved sequence involving generating the endpoint JavaScript from the blocks. You could see, where are you? Down at the user-defined functions, it defines the JavaScript for how the function is supposed to act, and then you take that code, copy it into a prefab intent that just created, and then you upload it to the AWS console, which I will do right now very quickly. Story demo. Use an existing role. Create function. And then function code, we upload this zip file that I've made that contains the code already. And then we save it. And then we connect this function to the developer function, and it should work. Let's test it. Alexa, tell me a story.
Story is usually defined as a record or narrative description of past events or, alternatively, a structure consisting of a room or set of rooms at a single position along a vertical scale.
Okay, so there are still some bugs to work out, but that's how the pipeline works in theory.